What is capacitor? Capacitor is also known as condenser. This is one of the passive components like resistive. Capacitor is generally used to store the charge. In capacitor the charge is stored in the form of electrical field. Capacitors play a major role in many electrical and electronic circuits. Generally, a capacitor has two parallel metal plates which are not connected to each other. The two plates in the capacitor are separated by non-conducting medium, insulating medium. This medium is commonly known as dielectric. There are different types and different shapes of capacitors available, from very small capacitors which are used in resonance circuits to large capacitors for stabilizing HVDC lines. But all capacitors are doing the same work, that is storing the electrical charge. The shape of a capacitor is rectangular, square, circular, cylindrical, or spherical shape. Unlike a resistor, an ideal capacitor does not dissipate energy. They can block DC and allow AC to flow through it, and this can couple one part of the circuit with the other. Circuits with capacitors depend on the frequency, so can be used to amplify certain frequencies. As the capacitors, when applied with AC input, the current leads the voltage, and thus in power applications it increases the payload power and makes it more economical. It allows high frequencies, and so it can be used as a filters, either to filter low frequencies or to collect high frequencies. As the reactance and frequency of the capacitor are inversely related, this can be used to increase or decrease the circuit impedance at certain frequency and can be used as filter. Likewise, capacitors exhibit many properties when used in AC or DC circuits, and hence they play important role in electrical and electronic circuits. Construction of a capacitor. As said before, there are different types of capacitors. These different types will have different type of construction. A parallel plate capacitor is the simplest capacitor. Let us understand the construction of this capacitor. It consists of two metal plates separated by a distance. The space between these two plates is filled with a dielectric material. The two leads of the capacitor are taken from these two plates. The capacitance of the capacitor depends on the distance between the plates and area of the plates. Capacitance value can be changed by varying any of these parameters. A variable capacitor can be constructed by making one of these plates fixed and other moving. Dielectric of a capacitor. Dielectric acts as an insulating material between the plates. Dielectric can be any non-conducting material such as ceramic, waxed paper, mica, plastic, or some form of a liquid gel. Dielectric also plays an important in deciding the value of capacitance. As the dielectric is introduced between the plates of the capacitor, its value increases. Different dielectric materials will have different dielectric constants, however this value is greater than 1. Dielectric can be of two types. Polar dielectrics, these dielectrics will have permanent dielectric movement. Nonpolar dielectrics, these will have temporary dielectric moment. By placing them in an electric field they can be induced with dipole moments. Complex permittivity. The product of the relative permittivity, epsilon r, of the dielectric material and permittivity of free space, epsilon o, is known as complex permittivity or actual permittivity of the dielectric material. The expression for the complex permittivity is given as follows. Epsilon equals epsilon 0 asterisk epsilon r. The value of complex permittivity will always be equal to the relative permittivity, because the permittivity of free space is equal to 1. The value of dielectric constant or complex permittivity varies from one dielectric material to another. Some standard values of complex permittivity, epsilon, for common dielectric materials are air equals 1.0005, pure vacuum equals 1.0000, mica equals 5 to 7, paper equals 2.5 to 3.5, wood equals 3 to 8, glass equals 3 to 10, and metal oxide powders equals 6 to 20, and etc. Capacitors can be classified according to the properties and characteristics of their insulating or dielectric material. They are given below as high stability and low loss capacitors: mica, low-K ceramic, and polystyrene capacitors are examples for this type. Medium stability and medium loss capacitors, paper, plastic film, and high-K ceramic capacitors are examples for this type. Polarized capacitors, example for this type of capacitors are electrolytic, tantalums.